Hey, what is going on, guys? Welcome back to another video. And in this video, we're gonna take a look at one of the popular Uber interview questions for their front-end interview, which is the map limit. So we'll take a look at what the question is, how to solve it, and how can you get to the solution. So without any further ado, let's get started. So let's try to read through the question first and try to understand what is the ask, so that we can actually build the solution and see if it works. So it says implement a map limit function that is similar to array map, which returns a promise that resolves on the list of output by mapping each input through an asynchronous iterative function or rejects if any error occurs. It also accepts a limit to decide how many operations can occur at a time. The asynchronous iterative function will accept a input and a callback. The callback function will be called when the input is finished processing. The first argument of the callback will be error flag and the second will be the result. So this sounds like a lot, but if you really boil it down to what it really means is you need to create a function, a higher order function, because it takes in another function as an argument. So your input is a async function, a limit, and an array of inputs. That's it, right? So your map limit function will have the iterative that they're talking about, this asynchronous iterative function, which is this, an asynchronous function, limit, because it also talks about, hey, you can, it should be adjustable, configurable by the end user. So we take in a limit and the array of inputs, right? This is the input. The async function takes in an input and a callback that is called once the processing is done. So this async function is basically this block. So the async function will have a signature like the first argument will be the input and the second argument will be a function that will be called, right? Let's just call it callback for now. So the input that I'm referring to is one of the elements from the array, and it will the function will do some processing on it, and then the callback will be called inside of that function. So yeah, that's the async function, and your output is basically a promise, right? So if you really boil it down to it's pretty simple. Now let's try to understand how do you get to this solution. So what I would prefer is showing you how does it work pictorially rather than reading through the code. If you guys are interested, you can always pause the video and then maybe read through the code. But I would highly recommend that you also watch like a illustration of this so that it makes a bit more sense. So here we are in Xcali draw. So, okay, so let's just try to understand, right? So there is this map limit function. Map limit function. This takes in a function. So let's just call it fn. There is a limit. Let's just call it L. And there is an array of inputs, right? So this is A. So this is basically the signature of our map limit function that we are trying to build. This fn is passed by the user. So whoever uses this map limit function will pass in the fn. L and A will basically just be, A will be an integer, A will be an array of something, maybe an array of integers in our case, and then L will be a limit, right? So let's just also talk about this fn, right? Because this is also important. So the fn is a function which takes in a input, which is basically an item from A. So let's just call it item from A. And it also takes in another function called callback. Right, callback. Yeah. So so the ask is that whenever this fn is done processing, it will call this callback, and then our function will take over, which is the map limit function that we are trying to build, and then it will resolve on the value whatever fn returns, right? So the catch here is that you need to follow a limit. What I really mean by that is, say I have an array, right? So let's just say I have an array of 1, 3, 7, 8, and 9, right? And I have this fn, which I'm passing here. So what it basically does is it multiplies whatever I pass in. So let's just say fn. So this takes in a num, This takes in a num and it takes in a callback. Let's just say C, which is passed by our mapLimit function. And then what does this do is just, n into 2, and then whatever the value is, it will pass it to the callback function, right? So it will pass in two things to C. It will pass in an error, if any. So in this case, it is null, and the value of this, right? So let's just say it is res, right? So essentially what we want is this will return me a result of something like this: 2, 6, 14, 16, and 18, right? So this is basically 9. Yeah. So this is the expectation. It need not be an array, but this is the way. But the thing is, you cannot process all of this array in parallel, meaning you cannot create a promise and then, pass and then basically parallelize the processing of 1, 3, 7, 8, 9 together. You have to follow this restriction that is limit. So let's just say this is 3, right? So what this really means is we have to start processing 1, 3, and 7, and then basically take a pause till 1, 3, and 7 execute. Once these execute, we'll then process 8 and 9. And since after 9 there is no other number, we'll just return the result, right? Now, this limit adds another layer of complexity, because now you need your function to stop once your limit is reached. Once there is more capacity to process, we'll just enqueue 8 and 9, right? So let's just see how we can deal with this, right? So let's try to go back to the basics, right? So I have an array. Let's just say 1, 2, 3, and 4. I have a limit set of 2, right? So we anyway have to iterate over the array, right? So we'll first iterate over the array. So 1, 2, 3, 4. So we'll have a function. So we'll have a for loop which will iterate over the array, and it will check for L. So we can have another local variable, which is we'll just say it CL, which is current limit, which will start with 0. And if it is 0, what we will do is we'll actually wrap the processing of 1, like whatever the fn is being passed, into a promise, and then we'll push it into an array, right? So L is equal to 2. So what will happen is there will be a promise for 1 and there will be a promise for 2, right? Because that is our limit, right? So now we are storing this in an array, right? And what we'll do is we'll wait for all of these promises to resolve, right? So we have a function called promise.allSettled. So it takes in an array of promises and just waits for all the promises to resolve. So we can leverage that function here. So we'll wait for P1, P2 to resolve. And once it does, we'll actually decrement CL. So we'll decrement it and it will go back to 0. And then again, right? So we can iterate then again with P3 and then P4, right? And then once we are done with this, we'll just return back the result, which if we take the previous function, which is multiplying the number by 2, it will be 2, 4, 6, and 8, right? Now let's try to see how we can wrap these things into a promise, wrap the fn that is being passed, and how we can actually resolve or reject based on the result of that fn. I think once we go to the code, that part will be clear. But this is basically the general approach that is being taken, right? You iterate over the array. Once you hit limit L, stop, wait for whatever the promises are there in the array to resolve, decrement the current limit, then again start with it, right? So every time you put something in this array, this promise array, you are going to increment CL and check every time that, hey, is CL equal to L? If it is, then stop. Wait for the array of promises to resolve. So this is the overall implementation. Now let's take a look at the code and just try to understand how it works. So now this is the code. So we have the function mapLimit, input, which is your array, limit, and the fn, right? So the fn is something that the user will pass. Will set a local limit, which is L is equal to 0. It will start from 0. will have a processed, which will be the final array, which will have all the data, which will have all the results. They'll have another local variable p, which is again an array. This will be the array of promises that we talked about before. And then we'll iterate over the array, right? So we'll iterate over input. And then if we'll check if L is equal to limit. If it is not, then we do something interesting, right? So what do we do? So we create a new promise with a callback, which is resolve and reject. And then remember that the FN that the user will pass in has a defined signature. So the signature is that it will take in an array element and it will take in a callback. Now the callback is something that we decide, right? The mapLimit function will decide. So here is the callback function. So the callback signature is defined. The first element is error, if any, and the second element is the value. So once we get the callback, it means that the processing is done. And what that means is I can reduce L by 1, right? Remember, there is a limit. So we'll reduce L by 1. We'll check if there is an error. If there is, then we'll just say, hey, reject failed. If not, then we'll resolve on that value, right? And once we create this promise, we have to increment L, right? Once the processing is done, we decrement L, but before the processing is done, we have to increment L so that, we don't breach the limit, right? So this is basically what we do if we don't reach the limit, right? So your P will be an array of promises. So once we reach the limit, what happens, right? So this is in the else block. So we'll await. So this will basically pause the function, right? If you try to do this with promise chaining, it won't work. What await does is that it temporarily suspends the processing of the next line, right? So your function processing will basically temporarily suspend if you use await, right? It tries to give you an impression of your code being synchronous. It's really not, right? So it will temporarily suspend till the promise is resolved, and we'll take the input. So we'll take the output of all of these resolved arrays as res, and then we'll check, right? If any of these promises are rejected, meaning, the callback, the processing here, the function that was passed, here fn failed, and then it passed in that error value to the callback function. Then what we do is we'll just throw an error saying that, hey, promise rejected, right? Let me go down. Yeah, here. So if the status is rejected, we'll just throw an error saying that, hey, promise rejected, right? Because there and then we have to stop processing. We cannot continue processing. But if that particular batch actually passed, then what we do is we'll map over the res, we'll take out the value, and then we'll basically concat it with the processed value, right? So we are just pushing whatever is in res.value into processed array. That's pretty much we are doing, right? We are just picking up the value and then just putting it into processed, right? If the limit is 5, then what we are basically saying that there will be batches of 5 items that will be parallelly processed, right? And then this particular block is interesting because, for example, say you have an array of say 7 elements and then you have a limit of 5, right? So even after you have iterated over all of that array, you won't hit the limit, right? So let's imagine this, right? Let's just go back to Xcali and I'll try to explain what is this part. So imagine this, right? So you have an array of 5 numbers. So 1, 2, 3, 4, and 5, and you have a limit of 3, right? So in the first iteration, so once we hit the first limit, it will be 1, 2, 3. You will hit the limit here, right? Now, but you still need to process 4 and 5, right? So now we'll process 4 and 5, but see here that we are not hitting the limit, right? So there are only 2 things in the array, but we are done processing all of that array, right? So we cannot just, ignore the results of 4 and 5. That's why we have this block here, which will first see that, hey, if p.length, that is the array of promises, if it is not equal to 0, then just wait, which is basically just the same here, and just concat, and then just return processed, right? So I missed one detail. So I decrement L by 1, right? So this is because when I'm on the boundary, meaning 1, 2, 4, 5, and 6 are done, 8 is something that gets missed, right? Because this is on the boundary, right? So these 5 numbers and then 8. So 8 doesn't get processed because for that particular I, the loop has already executed, right? Because the limit has been hit, it waits for else, and there is no processing for 8, right? So I added I minus minus here. And now if I try to run this, I'll also try to explain it via illustration. Yeah. So as you can see here, I've taken this array 1, 2, 3. So 2, 4, 6, 8, 10 were processed in a batch, and then 16, 38, 68, and 12 were processed later, right? And then I have another chaining here, which will just print that array together, right? So this is pretty much that problem. Now let me just try to illustrate again why I did I minus minus, right? So looking at the same example here, so let's just say L is equal to 3, right? So while I'm processing 1, 2, and 3, I haven't hit the limit L, right? So my I will be 0, 1, and 2 for these, right? Now when I is equal to 3, I'm hitting the limit and I go to the else. So I miss processing 4. That's why I do a I minus minus once I'm processed all of this batch, so that I goes back to 3 and then I start processing 4 and 5, right? If that makes sense. So yeah, that was the I that was missing. I think this was a fun question that I really enjoyed solving. If you want to see videos like these, please let me know in the comment section below. I hope you learned something new. If you have any questions or if you have any alternate approach to solving this, I'll be happy to look at that. So do leave, so please leave a comment and I think we can discuss there. But thank you guys for joining, and I'll see you guys in the next one.